Good morning, students. Today we will continue our chapter 9, that is mechanical properties of solids, and the topics we will be covering today are elastic limit, Hooke's law, modulus of elasticity, types of modulus of elasticity. So let us begin. So first of all, what is elastic limit? So elastic limit is defined as the maximum stress within which a body regains its original shape and size after removal of deforming force is called as elastic limit. And students, note that if the deforming force exceeds the elastic limit, the body acquires a permanent set or deformation and it is said to be overstrained. Okay, let's see the next one. So here we'll study Hooke's law. So in Hooke's law, Hooke stated that under elastic limits, the stress developed in a body is directly proportional to the strain produced. We have already talked about stress and strain in our previous lecture. So here, according to Hooke's law, stress is directly proportional to strain. If stress increases, proportionally strain also increases. Okay, so when this proportionality sign is removed, there comes a constant. So stress is equals to constant into strain, and here this constant is taken as E. So here stress upon strain will be equal to E, and stress is denoted by the symbol sigma and strain is denoted by the symbol epsilon, where E, which is a constant, is called as modulus of elasticity of the material, and E is also called as coefficient of elasticity of the material. Okay, students, let us see the next topic. So our next topic is modulus of elasticity. So modulus of elasticity is simply the ratio of stress to the corresponding strain within the elastic limit. As we have just studied in Hooke's law, modulus of elasticity E is equals to stress upon strain. And the SI unit of modulus of elasticity is Newton per meter square. And its dimensions are also given here that you will be studying in part 1. Let us see our next topic, that is types of moduli of elasticity. So corresponding to 3 types of strain, we have 3 important moduli of elasticity. So let us see what are they. So first one is Young's modulus. It is denoted by letter Y, and that is the modulus of elasticity of length. Second one is bulk modulus, denoted by K, that is the modulus of elasticity of volume. And the third one is shear modulus, also called as modulus of rigidity, denoted by neta, that is modulus of elasticity of shape. Let us begin with Young's modulus of elasticity. Okay, so here Young's modulus of elasticity is defined as the ratio of normal stress to the longitudinal strain within the elastic limit. So normal stress acting perpendicular to the body. Okay, so we have already studied about this longitudinal strain in our previous lecture. So Young's modulus Y is equal to normal stress upon longitudinal strain, and just putting their values, normal stress equals to force upon cross-sectional area, and longitudinal strain is equals to change in dimension upon original dimension, that is change in length upon original length. As you can see, refer to the figure also here. This is the original length when the force was applied. This is the change in length. So here longitudinal strain is change in length upon L. So here you get Y is equals to FL upon A del L. So students, if the area of cross section of that wire is circular, then here you will simply put area is equals to pi r square. So I have, just for your better understanding, I have put here that area will be now pi r square y is equals to FL upon pi r square delta L. Okay. So units of Young modulus will be Newton per meter square or Pascal, and in CGS unit it is dyne per centimeter square. Let us move to the next one. So our next topic is bulk modulus of elasticity. So let us see what is that. It is defined as the ratio of normal stress to the volumetric strain within the elastic limit, where K is equals to normal stress upon volumetric strain, that is minus F upon A upon delta V by V. You might be thinking why there is a minus sign here. So students, when pressure is acting on all sides normally, okay, then there is a decrease in the volume of the body. So you can see that this one, so here the outer one, the volume is represented by V. The change in volume, this portion is represented by del V, and the volume, this is represented by V minus del V, that is change in volume. So due to the decrease in the volume, this negative sign is put here. Okay. So the formula came here is that K is equals to minus FA into V upon del V equals to minus P V del V. Why this now? So students, force upon area can be written as P. So P is equals to FA. You already know pressure is equals to force upon area. The unit of bulk modulus of elasticity will be Newton per meter square or Pascal, and in CGS unit it would be dyne per centimeter square. Let's move to the next topic. So our next topic is compressibility, and compressibility is nothing, it is just the reciprocal of bulk modulus of the material. Okay, so compressibility beta is inverse of modulus of bulk modulus of elasticity, that is 1 upon K. So SI unit would be Newton to the power minus 1 meter square, and in CGS unit dyne to the power minus 1 centimeter square. Okay, next. So let us see our last topic, that is shear modulus or modulus of rigidity. So it is defined as the ratio of tangential stress to shear strain within the elastic limit. So students, shear stress or tangential stress is equals to force upon area, and this force is acting tangentially to the surface. Okay, this we have already talked about in our previous lecture. Shear strain, that is tan theta is equals to delta L upon L, where this theta is equals to the displacement between the opposite surfaces is represented by delta L and to the original length L. So where shear strain is theta is equals to delta L upon L. So modulus of rigidity neta is equals to tangential stress upon shear strain. Putting the values, neta is equals to force upon area upon theta, that is F upon A theta, where theta is equals to delta L upon L. So putting the values, we get FL upon A delta L, whose unit is Newton per meter square, and CGS unit is dyne per centimeter square. For any doubts, you can contact me on my personal WhatsApp. Thank you. Have a nice day.